Hello everyone, greetings from South Africa. Today I'm going to talk about the, oh boy, interesting story of our water tower. This is going to be long because every other project that we had faced challenges. However, this one, it was a challenge from start to finish. It was special. It taught us a lot. We all grew as a team and as individuals. But before I get too emotional here, let's dig right in. As per usual, I made a construction. The drawing of it you can see here. And I deviated slightly from certain standards set in Europe because we have a few peculiarities in the Gambia. The first is that I massively increased the safety factor that I calculated with. Usually you calculate with a safety factor of 1.5 to 2, and I calculated with a safety factor of 4. We know that we have 5 tons of water on the top, and I calculated with a weight of 20 tons. I did that in order to have ridiculous safety margins should something of the construction not be up to the standard. It will still hold because the safety margin allows for it. For the construction, we used 2 different kinds of materials. We used them because they are available and they have the properties that we need. The first material we used for all of the structural members, so everything that needs to hold something or carry a heavy weight. Those are 100 by 50 I-beams, so they are 50 millimeters wide and 100 millimeters high. And they are very strong, and you can pretty much put pressure and weight in all directions on them and they will hold it because of their special shape. The other material that we used are square steel tubes. They are called 40 by 40 by 1.25. It's pretty much 40 millimeters high, 40 millimeters wide and 1.5 millimeters thick. And we use those pipes in all of the less stressed areas of the construction and all of the areas where you need to distribute a load over a wider area. We started the actual building process of the water tower with the platform the water tank stands on. This platform serves 2 purposes. First, to distribute the weight evenly onto the 4 legs. And second, to support the bottom of the water tank so that it doesn't break. We started with the frame. We made that out of the square steel tubes that we bought for that purpose, and then welded a grating made up of square steel tubes as well into the frame. The spacing was very narrow so that the bottom of the tank gets properly supported. Underneath we have the first structural member made out of the I-beams, and that is a secondary frame to which we are going to weld the legs. We used a secondary frame to support the legs because you always have structural members connected to structural members. Otherwise, the frame might not be strong enough to support the weight properly and to distribute it evenly. When we had that, safety concerns came in. We put a railing onto the platform because we will have to periodically check up on the water tank, maybe fix the sensor that is inside. And let's be honest, the water tank is 6 meters high. When you stand on top, you have a perfect view over the very beautiful countryside and the entire farm. So we built a railing strong enough that even if you lean against it, it will hold you. Left an opening so that you can access the platform with ease, and built a ladder also out of the square steel tubes so that you can scale the water tower relatively easy. After we were done with the platform, we faced the first little challenge that we had with the water tower. We had to attach the legs. Since the legs are angled in two ways, first outwards and then downwards, so that they can handle wind loads from all directions, we had to angle them properly. Otherwise, the water tower would be crooked and it couldn't hold in all of the directions equally. But how do you do that? How do you make sure that 6 meter long legs are all perfectly angled in the right way? We actually used two methods for that. The first method is experience. Our welder who actually built the water tower is a very experienced man. He has a keen eye, he has built multiple water towers of different construction, but the basic principle is the same. So from muscle memory, he actually knows how to build these things. And secondly, smart design. What I did is that the square that the bottom of the feet forms coincides with the dimensions of the platform. So when you take the platform and put it from the horizontal in the vertical, you can actually put the legs onto the secondary frame and angle the legs outwards to a distance of 3 meters and rest them on the ground, and that makes sure that all the angles are right. Then, when the two bottom legs are fitted, you turn the entire construction by 90 degrees, and then you weld on the top legs. And so you make sure that all the angles are correct and that the distances between the legs are all equal. After the legs were attached, it started to look like a water tower. However, every structure needs to be able to handle a lot of various loads. As an example, the water tank pushes from the top, but wind pushes from the side. And depending how strong the winds are and from what direction the winds are coming from, the water tower needs to be able to handle not only loads from the top, but also from the side. Therefore, you need to reinforce the water tower. Not with I-beams, that is a little bit of an overkill, but with the square steel, so that the water tower doesn't twist like this, or that the legs don't bend inwards like this. So reinforcements were welded on, and when that was done, we had to future-proof the water tower. And we did that with rust-proof paint. We used the omnipresent standard iron oxide red color that some of you might be familiar with. So our water tower has a reddish color and it looks okay. And thank God it keeps the water tower from rusting in the rather trying environment of the Gambia, where you not only have the rainy season, but also the sandstorms sandblasting the water tower during the dry season. The last step of the building process of the water tower was to weld feet onto the legs. The feet have the same purpose as our feet, to distribute the weight over a bigger area so that the water tower doesn't sink into the ground. We used square steel plates of 1 centimeter or 10 millimeter thickness, welded onto the legs and with a hole in each of the 4 corners so that we can screw it into the concrete blocks that we put into the ground to further distribute the weight. And that is, again, a very nice bridge to the next topic, preparation of the ground. You can't just bolt a structure like this onto the ground in the hopes that it might hold. You always have an uneven area, and when it starts raining, the top soil gets washed away and the soil becomes soggy. So you need something that further distributes the weight, goes deep enough that it is actually held in place even if the top soil gets washed away. And a very good material for that purpose is concrete. Concrete reacts brilliantly under pressure, and you just dig a hole, like we did, of the right size, and you pour it inside and it dries by itself. And if you treat it nicely by covering it up and watering it once a day as long as it still dries, it won't crack and it will have enough strength to hold a water tower, and that for extended periods of time. What I hinted on earlier is that you always have to work with uneven ground, and you can either make it nice and flat, which tends to take a lot of equipment and a lot of time. So we went a somewhat different route in that we built the foot on the highest point, level with the ground, and raised the other 3 feet above the ground, so that the 3 above the ground are level with the one on the highest point. For that purpose, we built a wooden box and put it on top of the foot in question that needed to be raised, so that when the hole that we dug into the ground was completely filled with concrete, that we could go beyond without the concrete flowing everywhere. To make sure that all 4 feet are truly level, we took one of our square steel tubes, put our water or spirit level on top, and measured again and again, also diagonally, to make sure that the water tower in the end will stay straight. And now we faced our first real setback in the entire project, and this in particular. We don't have footage of that, so here I am. When we tried to erect the water tower for the first time, we tried to pull it upright with the Toyota after our employees pushed it up to a degree that we can pull it straight. Unfortunately, we didn't raise it high enough, and when the Toyota started pulling, it exerted a force not upright but forwards, and under the stress for which they were never designed, the legs bent and buckled, and the water tower fell back to the ground. Thank God nobody was harmed, and the damage, although severe, was repairable. Of course, we were all very sad, yet grateful that nothing major happened. And after we collected ourselves, we surveyed the damage, made a plan on how to repair it, and started on that. The foundations, the concrete feet were alright. There were only a big scrape on one of them, but that was negligible. 2 of the feet we actually had to cut off and build replacement feet from new I-beams, because the old ones, once you bend metal beyond a certain point, it loses its strength. And I didn't want to risk to test how much of strength was lost, so we cut it off and welded our shiny new replacement feet onto the stumps. However, a weld is always a weak point in a construction, so you always want to make sure that they are strong enough to bear the load that you designed them for. We also used something called a fish plate. Pretty much you have your construction, and you take a metal plate and weld it onto the initial one. In our case, we had I-beams, so per fixed leg we had 4 fish plates, one each side in the middle, one each side on the flanks. And in order to strengthen the construction further, We drilled holes into the plates so that we are not only welding around the seams, but also through the middle. With the water tower repaired, it was time for the second attempt to erect it. Of course, we didn't just repeat the method that we used for the first attempt, but we devised a new system. We discarded with the Toyota. If something goes wrong, it has way too much power. It would bend the legs again if push comes to shove. So we got help from the village, many more hands to help us erecting the water tower. And we built, let's call them crutches. It's pretty much a pole with a hook on the top, so that when all the arms are stretched out, you have something to push the water tower higher up to the point where it self-erects. And that was successful. Water tower was intact, the people as well. And then we actually hit our second setback of the project. We found out that the new legs were 20 centimeters too long. And that is the reason why ever since we are training measurements every morning at the farm. So we grabbed our angle grinder, shortened the legs by 20 centimeters, and put the legs back onto the feet. Now that our water tower was finally standing upright, it was time to fit it with expansion screws into the concrete feet. We did that because the water tower could still shift. As an example, a big animal could try to use it as a scratcher and thereby pushing it around. With the water tower now erect, it was time to put the water tank on it. That caused a little bit of a struggle because of our railing. Usually you are tying a rope around the throat of the tank and pulling it up like that. But our railing was in the way, so we devised a somewhat different system by tying the rope around the body. Thereby the tank was helping us with its curvature to manhandle it over the railing. Once that was done and up, we connected it to all of the pipes and pressure tested it. And in order to keep the tank in place on the platform, we built, let's call it a harness, to keep the tank in place. The harness was welded onto the platform, and that left us with only one more thing to do. My beautiful wife designed a logo for us, and we are very proud of that. So we got ourselves a flag with that logo, and we took the longest square steel tube that we had from the building process left over, welded an eye to it, got 25 meters of rope, tied the flag to it, and now we can very proudly show who we are with a flag that can be seen right from the road that is roughly 0.5 kilometers away. And that's it. That is how we built our water tower. It was quite the adventure. I'm very proud of the team, especially how they handled the various setbacks and how they kept on grinding and working. And I am quite pleased to see something that I dreamt up in my head becoming a reality and evolving during the process to something that is truly a team effort. Next time, I'm going to talk about our bathrooms. See you next time.